Good morning, students. Am I audible? Okay, so where we are in the last class, I think we have discussed the relationship between your depth of flow before the jump and after the jump. Okay, then I don't remember we discussed loss of energy or not. Loss of energy is over. Loss of energy is over. We have discussed loss of energy. Okay, okay. So we have completed loss of energy. Then efficiency of jump. Efficiency of jump. Yes, okay, fine, fine. Then we can directly move on to, I think, numericals, okay? I think height of the jump also we have discussed. Length of the jump. Okay, fine, fine, fine. Okay, okay. So you write next topic is types of jump, okay? Okay, length of the jump is also over. Then we can directly move on to the numericals, okay? Okay, okay. So first numerical, you just write down the question, okay? 7.1. You write down the question or example 7.1. Done. So what's given in this equation? We have to show that yc cube is equal to y1 y2 multiplied by y1 plus y2 divided by 2. Okay. So for a rectangular channel, we have to prove that our critical depth whole cube is equal to this for a rectangular channel, horizontal rectangular channel. Okay. And this is valid to create an hydraulic jump. Okay. We have to prove. So what we are going to do, we first consider this equation. Okay. If you remember, we have already derived this equation for deriving the relationship between y1 and y2. If you remember, I'll just show you the expression. Okay. So this is your loss of energy in jump. Okay. Or else you can here also see here the jump analysis in rectangular channel. Okay. During this, we have already derived this expression. You can see here this expression. Okay. So we are directly going to use this expression. Okay. So this derivation we have already discussed. Okay. So we are not going to discuss again this derivation. Okay. So we are directly going to use this expression to solve that numerical. Is it okay? Clear? Okay. So we will go back to the numerical and we are using this equation. Okay. 7.4 for or to solve the numerical. Sorry, to solve the numerical. Okay. So here we use this expression. Okay. Same expression. Then we see we have to bring yc here because we have to prove yc cube is equal to this. Yc cube is equal to this y1 y2 y1 plus y2 divided by 2. Okay. So to bring yc, we all know for rectangular channel yc is equal to q square divided by g to the power 1 by 3. Okay. We have derived this expression already. Okay. I think in specific energy chapter. Okay. So critical depth is equal to q square by g whole to the power 1 by 3. This is for rectangular channel. And here also they are asking for rectangular channel. So what we are going to do, we bring this as here. So it will be yc cube is equal to q square by g. You can write like this also. So here, if you see we have q square by g. Okay. So we bring this to the other side. Okay. So it will be negative, so here it will be positive. Okay. So twice will be there. We have q square by g is equal to y1 y2 square plus y1, sorry, y1 square y2. Okay. So here q square by g is there, so in place of q square by g we will substitute yc cube. Okay. You can see here in place of here q square by g, in this equation we directly substitute yc cube. Over. Okay. So after that, we are going to substitute this y square by g is equal to yc cube here in this equation. Okay, in this equation. So in y square by, sorry, q square by g, we will write yc cube. Then here in this, in right hand side, we have y1 y2 square. Okay, plus y1 square y2. Okay. So what we are going to do, we are going to take common as y1 y2. So here we have y1, y2 is there, we will be having y2 plus here also we have y1. Okay. So if you remove this bracket, you will get this part again. Okay. So this y2 plus y1 or y1 plus y2, same thing. You can write y1 y2 y1 plus y2. Okay. And if you bring this 2 in the right hand side, it will be divided by 2. Okay. So here you are getting this. Okay. Over. Okay. So you write the next numerical. Okay. 7.2. 7.2. Just write down the numerical. Over. So what is given here? We have a sluice gate in a rectangular plane, and then once you open, so before the jump, the depth of flow is given 1.8 meter, and velocity is also given 24 meter per second. So what we have to determine first, sequence depth. That means y1 is given, we need to find out y2 value. Okay. Then height of the jump. Okay. Then length of the jump, loss of energy in the jump, efficiency of the jump. Okay. So these are the, sorry, another we have types of jump, and then ratio of Raoult's number. Okay. So first, if you remember that the first one is to find out the sequence depth. That is what y2 value. So if you remember the equation, y1 divided by y2 is equal to half, then you have minus 1 plus root over 1 plus 8 fr2 fr2 square. Okay, so this is the equation. See, if y1 divided by y2, so if you put y2 at the denominator, here will be fr2. Okay, so now we have to find out y2 value. Unless and until you have y2 value, you cannot find out fr2 value. Okay, so what we are going to do, we are not going to use this equation, we are going to use the reverse equation, y2 divided by y1, everything will be same. Okay, half minus 1 plus root over 1 plus 8 fr1 square. Okay, whatever here it is in a denominator, it will come like this, fr1 square. Okay, so we are going to use this expression. Okay, we have two expression. If you don't remember, then we go back to that derivation or jump analysis. Okay, okay, see, we have two equation. One is this, y2 divided by y1 is equal to half minus 1 plus root over 1 plus frn square. When y1 is in the denominator, you'll be having fr1. Okay, here if you see, the another equation is this, everything will be same. Okay, if you reverse the thing, then here will be fr2. So whatever the value or whatever the term here in the denominator, that represents the fr. So if that y2 value is the denominator, so it will come fr2. Okay, so we are going to use this expression, the first one. Okay, as y2 we need to calculate, y1 is given, and we need to find out the fr1 value. Then we substitute here and we find out the y2 value. Okay, so before we do this expression, or before we need to find out the y2 value, we have to find out fr1 value, then only we can calculate y2 value. Okay, otherwise we cannot use this expression. Okay, so we are going to find out first fr1 value. Fr1 is Froude number for before the jump. So we have v1 divided by root over gy1. Okay, so v1 is already given 24 meter per second, g value is 9.81, and y1 is also given 1.8. So you can directly find out the fr1 value. So you do the calculation and see you are getting the same value or not. Okay. So then after this FR1, we need to find out the Y2 value. So we are going to use this expression. Okay. Y2 by Y1 is equal to half minus 1 plus root over 1 plus 8 FR1 square. So Y1 value we have already known, or it's given. Y1 is 1.8, okay, meter. Okay, so FR1 we have just now we have calculated. So you use this expression and find out the Y2 value. Okay, I think you will be getting around 13.66 meter. Okay, so this meeting is going to end very soon. So you just rejoin. Okay, I'm going to disconnect this meeting and you just connect again.
By the way. Yes.